Hello, welcome to the wonderful world of Algebra 2. This is Chapter 5, Lesson 2, Polynomials, Linear Factors, and Zeros. All right, so we know that degree is increasing, and we're going to learn how to find its solution. This is very similar to what we already did with quadratics, writing a polynomial in factored form. So then we'll be able to solve it by factoring eventually. So you can see the concept is going to be the same, right? To factor, you'd always look for a greatest common factor first. So we can see in these three terms, we could bring out an x. If we bring out an x, that's going to leave in x squared minus 2x minus 15. So then we can see what we have left inside is a riddle. So we can factor further. So we have x on the outside. Now our riddle gives us our two binomials, starting with x. What multiplies to give us negative 15? Adds to give us negative 2 would be negative 5 and positive 3. You can see we have three factors now because this is a degree 3. Number 2, greatest common factor is x, leaving inside x squared minus 25. That leaves us a difference of two squares. We have x on the outside, difference of two squares, two binomials. There we go, x plus 5. X minus 5. So once again, we can see now our degree 3 is giving us three factors. All right, so finding zeros of a polynomial function, right? These will be our solutions, and then we'll work backwards and get the equation. So we've got y equals x plus 2 times x minus 1 times x minus 3. So now this is already in factored form. Right? So just like we did with quadratics, to find the solutions then, we can take our factors, set them equal to 0, and solve them. So x plus 2 gives us an answer of negative 2. X minus 1, we get positive 1. And x minus 3, we get positive 3. So this means that we are crossing the x-axis at negative 2, at positive 1, and at positive 3. All right, so then to do the graph by hand, we can also consider the end behavior. If I were to multiply this out to get the leading coefficient, I would get that by multiplying the first terms of all the factors. So I think, let's see, what is x times x times x? That would be x cubed. So you don't necessarily have to write this, but this is what you're thinking in your brain. So x cubed is a positive odd. Right? Positive odd. So odd degrees go opposite ways. So just like a line that's positive, it's going to go down on the left and up on the right. So I know my graph here from this last point, it's going to go down. And from this, I guess you call it first point, or this furthest right point, it's going to go up forever. So then what I have to determine is how curvy is this in between here. To do that, I could pick values that were not solutions, that were not zeros here. So I could start with in between 1 and 3, I could plug in 2. I need a little room here. So if I plug 2 into this, if I do f of 2, well, 2 plus 2 is 4. 2 minus 1 is 1. 2 minus 3 is negative 1. 4 times 1 is 4, times negative 1 is negative 4. So that gives me the point 2, negative 4. So 2, negative 4. I could plug in between 1 and negative 2, I could plug in 0. So if I do f of 0, I'm looking at 0 plus 2 is 2. 0 minus 1 is negative 1. 0 minus 3 is negative 3. 2 times negative 1 is negative 2, times negative 3 is 6. So I've got the point 0, 6. Plug in one more, I'm going to plug in negative 1. So I've got the point, let's see, negative 1 plus 2 is 1. Negative 1 minus 1 is negative 2. Negative 1 minus 3 is negative 4, which gives us 8. So we've got the point negative 1, 8. Negative 1, 1, 2, 3, 4, 5, 6, 7, 8. So you can start to see where the graph is curving there, right? Where the graph is curving. The other thing that I want to show you is exactly to find out where is the top of this mountain going to be, where is the bottom of this valley going to be. These are called relative maximums and minimums. right? This graph doesn't actually have a maximum because it goes up forever. But each mountaintop would be a relative maximum. It's a maximum that's in a short little span. This doesn't actually have a minimum because it goes down forever, but it would have a relative minimum, which would be the bottoms of the valleys where they occur. So they're not happening at integers because I already looked at the integers there. So how you would find these is you would go to your graphing calculator, go to y equals, clear out anything that's there, put in the question. So we had x plus 2 times x minus 1 times x minus 3. Right? We can graph it and see what it's going to look like. And we can go to the table, right? Those points that we got plugging in by hand, we could have also found using our table. So then I can see here that these are all integers. So I want to see where that relative maximum is, where that relative min is. So remember, if you want to start at your graph, you can go to second trace to get to calc. And we've done 0 before. This time we're going to do the minimum or the maximum. It's the same process. So if you select 3, it's the relative minimum. So then you would scroll to the left of the relative minimum and hit enter. And I can see that that relative minimum is happening right there. I just don't know exactly where that is. So if I go to the left of it and hit enter, then I scroll to the right bound, to the right of it, hit enter, and then it will tell me where it is. MathXL is going to have you round to the nearest thousandth, so 2 decimal places. So I can see this relative minimum is happening at 2.12, comma, negative 4.06. So this graph is actually bottoming out at 1.2, negative, so it's like right there, right? It's just tiny little there. So that's where it bottoms out exactly. And then to find the relative maximum, we do the same process, right? We go second count, except this time we would pick number 4 for relative maximum. So then I would scroll to the, oops, I have to start over again because I hit the wrong button. So I'm going to go 4 for max. So I scroll to the left of where the maximum is and hit enter. Scroll to the right for the right bound and hit enter. And then I hit enter again when it says guess. So then I can see the relative max happens here at, the relative max rounded to the nearest thousandth was at negative 0.79, comma, 8.21. So the actual top of this mountain is negative 0.79, 8.21, about right there-ish, right? So that it would be the top of the mountain. That's how you find the exact places where the mountains top off, the relative maximums, and the relative minimums where the valleys are. All right, so again here, so we will do this some by hand, some on the calculator to see where it crosses. I set my factors equal to 0. So I've got x equals 0. If I take x minus 3 and set it equal to 0, I get x equals 3. X plus 5 would give me negative 5. So I know this is crossing the x-axis at 0, at 3, and at negative 1, 2, 3, 4, 5. Again, the end behavior is going to occur if I multiply the first terms all together. X times x times x, again, is going to give me x cubed. So this is another positive odd. So I know that positive odds go down and up. So this is going down to the left, up to the right. So then I could pick out other points, or this time, since I'm going to have to use the calculator anyway to find my relative mins and max, I could go to my calculator. Where are you, calculator? Go to y equals. I can clear out the last problem. This time I have x times x minus 3 times x plus 5. Yep. I can see it. It is beautiful. That red dot is in the way. So it's not really going to fit on the graph that they gave us. I can go to second graph to get to the table to find points. So there we can see, yes, it does cross at negative 5 because y is 0, 0 where y is 0, 3 where y is 0. I can find other points. whoa, this is up like crazy. So at -4, I'm at 28 and 36, 30, 16. So that tells me, yes, this is going up like crazy, and then it's going to come back down. I've got at 1, we're at -12, -14, and then we're back at 0. So I can see over here, it's doing the same thing. It's going to go down and then back up. So it's like off my graph. The mins and the maxes are happening off the graph. I can still find them, right? If I want to find my relative max and my relative min, I would use my calculator. So I can also see that on the table, like it's going to happen somewhere. I go from 0 to 28 to 36 and then back down. So that relative max is happening right there, right? Because I can see that this is a top. And then it's going down, 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 down. Right here at -14, then it turns around and starts going back up. So this is a bottom. So I know they're somewhere close to that. But to find out where they are exactly, I go second calc. I would erase that stuff so that you can actually see what's going on. To find the max, I would pick 4. I would scroll to the left of the maximum. So you can see it's off the chart. It's up there where I can't see it. So I'm at the left of it, enter. Now I'd scroll to the right of the max. I'm probably around, but I'll wait until I can see it to make sure. So there I am, boom. So I can see that the relative max is at -336. So this max actually did happen at integers. That's nice. So the relative max is at -336. So then to find the relative min, same thing, second calc. This time I pick 3 for minimum. So I scroll to the, where are we? We're at -2. You can follow the numbers there. So I'm scrolling. Am I going to appear? Oh. Come on down. There you are. So there I am to the left of the minimum. I'm going to scroll till I get to the right of the minimum. Boom. And this one not so pretty. Math Excel is going to have me round to the nearest 100. So we're at 1.67, comma, -14.81. All right, next thing we're going to do is we are going to write the equation, writing a polynomial function from its zeros. So if I know these are the zeros, where I cross the x-axis, I can work in reverse. I know that these zeros came from, if I had like y equals x minus -3, that would have been x plus 3. If I had a factor x plus 3, I would have gotten the 0, -3. Right, my other one would be x minus, I would type in the 0. The 0 is 3. So we're going backwards. This x plus 3 would give me the answer of -3 like I have over here. This x minus 3 would give me the answer of 3. So then, to get it into standard form, we'd have to multiply it out. So we would go x times x is x squared. X times -3, -3x. 3 times x, positive 3x. 3 times -3, -9. Like terms cancel, standard form, y equals x squared minus 9. So what you do is you take your roots, you take your zeros, plug them into x minus, and then you would simplify. So like here, we would go y equals, first one, x minus -2 goes x plus 2. X minus, second one is 2. X minus, third one is 3. So now we would distribute. So we get x squared minus 2x plus 2x minus 4. Cancel. We're at x squared minus 4. Then we have to multiply that by our x minus 3. So there we would be in standard form at y equals x squared times x is x cubed minus 3x squared minus 4x plus 12. In 30 seconds, let me try and tell you what a multiplicity is. If it happens more than one time. So like here, we know the 0 would be -3. It has a degree 3, which means it happens 3 times. So it has a multiplicity of 3. Here, you have an answer of 0. It only happens once, so that's good. You have an answer of 2, but since it's a degree of 3, this answer of 2 has a multiplicity of 2. Woo! I made it.